Welcome to Retro Upgrade. This is a special episode again. This is also sponsored by PCBway. This is a project video like the last one. This time we'll be tackling my newest project, the keyboard I designed for the ZX Spectrum. I've been teasing it quite a bit. You're going to see me try to test it out. You can see it over here in the screen. It turned out really good. It replaces the membrane on the ZX Spectrum. Hopefully you will enjoy the journey. You can see here me trying out some of the buttons. The buttons are extremely small. I think I screwed up on the type of button, unfortunately, but let's see if I can get this to work. So this is the design or the schematic I used. And this is the footprint. Okay, now let's take a look why I decided to design my own board. Two ribbon connectors, one here and one here. Let's disconnect these. These are just push-in ribbons. Yeah, they are. I ripped a ribbon. So while disassembling the board, I destroyed the ribbon cable. And I checked up on the prices and they were really high. I also tried to fix it, you can see here, but I failed numerous times. So I decided to design my own board and maybe make it a little less expensive. So this was my last option, pretty much. Okay, so first comes research. I researched a lot of different connectors and buttons. I found some decent ones on AliExpress. I thought I needed the thinnest ones possible, but that doesn't turn out to be the case. The ones I ended up choosing, I made a footprint for them because it didn't exist in the PCB software. Also, I made the outline of the old membrane in my FreeCAD software. Then I went for doing the schematic symbols for the switches and everything else that was missing. I found a few schematics online, but they weren't really pin compatible. I checked all the connectors. I made a connector as a symbol as well and a footprint. And then came routing. I tried to route manually like this with all the wires, but that didn't work out very well, so I ended up using some different routing later on. As you can see, I could import the actual footprint I made in my 3D software, and I put circles where all the buttons go, so I can align all the buttons. And the connectors come with it. This is a first preview, just the buttons and the connectors. And this is with the 3D model. It looks really decent. I tested the auto router, as you can see here, but it actually looked like a mess when it was done. So I decided to route it manually, just like it is on the original membrane. Routing it manually, it takes some practice to get right, but after a while you can actually get there quite easily. It's still a little bit time consuming because you have to check your work, but if you're following along with a schematic or of some sort or a wiring diagram, it's usually quite easy to follow along. So in this case, you have address lines that hook up to other address lines and you hook them together practically in a matrix. Let's export the Gerbers. I'm checking all the footprints and everything. These are all the layers. I removed the ones that weren't necessary and put them together. You can export them directly from the app, but I decided to make it cleaner for PCBway to print. Now a little bit from our sponsor today, PCBway. So I ordered it from PCBway. You can upload your Gerbers using the Gerber uploader. just choose your Gerbers and let them upload. And then you can also preview the Gerbers in the Gerber viewer. I usually do that because you can notice stuff you missed. For example, I missed the silk screen here with the logo for my channel and the PCBway logo. You can see the routing from the front, from the back, and even do X-ray mode, which is really awesome because you can see if one track leads to nowhere. That helps a lot. Okay, back to the ordering step. So I single piece on the board, one, and then I decided for 10 at the end boards because it was the same price as 5, but I keep 5 for now. 2 layers because I have 2-layer board, and I chose the 0.2 option. Here PCBway intervened and told me I should pick for 0.4 because of warping issues that could arise with such a big board. And I listened to them and ordered 0.4, and it fits fine. Okay, for next, I left most things at default. I don't touch much. The coating I did play around with a bit because it got really expensive if I put hard gold on it, but otherwise it stayed pretty much the same price. Same for the copper thickness. I usually leave it alone because it doesn't really matter for my application. It's a keyboard membrane. Actually, if the copper is thinner, it's better because it makes it more flexible, just like the real thing. And here I'm playing around. As you can see, it's changed for 30 euros. Okay, so this is for 10 boards practically, and it cost me about 130 euros. So that means it's 13 euros per board. For such a small amount of boards, it's pretty decent, I'd say. Okay, let's take a look at the finished product. So here are the buttons. I ordered these separately via AliExpress. The actual package from PCBway came very well packaged. It came with ESD safe what's it called, bubble wrap around it, and the 2 planks you can see, and the bubble wrap envelope. It turned out really well. It seems to be a through-hole scrap board or something, but I don't care. It kept my board safe. I already noticed a few things I want to change for next revision, but this will replace the membrane you see on the screen. The buttons, when you push down, the 2 silver contacts make contact and transfer the, what's it called, the current or the voltage. As you can see, it's fairly thin. It's 0.3 or so thin, and on the where the buttons are, it's 0.5 or so. So actually my board is thinner overall, and you can see it's super thin, and it's flexible. So there are a few concerns when I'm going to solder this, if it's going to bow or not, and it is actually bowed. But that doesn't matter because there's a membrane on top that straightens it out, and it's going to be pushed down with glue, so it's fine. Okay, now to show off my solder paste. I bought this from AliExpress. It's a low temperature melting solder paste. It's 138C. It was really cheap as well. Okay, so you can see these things are minuscule. I designed the pads around this for this button. So it's a button that's 3.7 millimeters squared and then 0.35 tall. So that's actually what's concerning me. It's so thin, you can see it here. It's super thin, but it doesn't have a dome shape. So they are quite hard to push down. I tried to push down on one of them on the table. It was really hard with the finger. I'm hoping the membrane or the rubber will deform enough to actually click on it. Okay, so let's use you can see the membrane here. It is indented, so I noticed I could actually fit taller buttons. So I'm going for a 1.5 millimeter tall button with a domed top. I can show them here, but for now, for testing, this is fine. You can see all the small holes in the rubber. Those line up with actual small pillars in the actual plastic case, and it's quite soft, this membrane. So I don't want a squishy membrane, I want a clicky membrane. So that's what this is. This is a mechanical keyboard practically. Okay, so you see these protruding things, these are the connectors. So I noticed I screwed up with the design. I made the design from a picture that was taken from the top, and I was guessing a lens distortion would screw me over, and it did. The bottom left peg is touching slightly, so we need to grind away a little bit. I left these pegs actually exposed underneath just in case if I needed to move them, so forethought. And you can also see these, because the PCB is thin, I need to slice them off farther down. They can't be this long because they hit stuff inside the case, but for now, for testing, that's fine. Maybe using one of these FPC connectors, not this many pins though, but these are for TVs. But that could be an idea, or just make the pins or these protruding things a little bit shorter. That should also fix the problem. And using ribbon wires. Okay, let's give it a test. I need to test solder 1 first. Oh yeah, I also need a connector for the motherboard side. So I ordered actually these from eBay, but they never came, so I have to make my own. These connectors should be 0.6 millimeters thick. So I found something that is similar. My prototyping boards, I checked the pitch and it's actually the same as the ribbon connector. So I can make my own. Okay, so let's go through first and do a test solder. The syringe is a little bit too big for this pitch, so it puts on too much paste, so I moved around. And that was an issue later on as well. By the way, I'm trying a new editing style. Give me a shout if you like it or not. This is a little more compressed. This was 16 hours of video total, designing and stuff. And I don't want to bore you with the details. If you need any extra additional information about any of the steps, just leave a comment and I'll make a dedicated video. So that jumped in quite nicely. Surface tension pulled it back. I was using 300C and 25% airflow. I found out the hard way, you should not put alcohol on this. It loosens the glue on the top of the shell, which is using Kapton tape. I didn't know that at the time, obviously. It is firmly soldered, so I'm happy with that. The solder paste works. Problem was when I pushed the button, it got stuck to my finger. So after a few clicks, obviously, you can see here it actually survived, and yeah, it came off. And it's a little dome with some Kapton tape, so you could see the contacts inside there, but yeah, the contacts actually just touched it inside and outside parts. Okay, now for a speedy montage of me putting down some solder paste and then putting down the actual buttons. Now heat them up. See, they solder completely. It bowed a little bit. Now to fix the imperfection or my design flaw, I just have to move that hole a little bit for next revision. My file is doing quick work of it. A quick test fit. And it slides right in. So it was barely half a millimeter. So let's get to making the connectors for the motherboard side. These are too thick, so I have to split it in the middle somewhere or grind it down. I decided to grind it down later on. Okay, so let's cut out 5 and 8. So one connector is 5 and the other one is 8 wide. So there is enough on one side to do this. I used a normal knife to do this, a hobby knife. And you can actually split it on the line when you score it enough. I score it from both sides and then use some tweezers or pliers to break it off, just slowly but surely. And then just snap them exactly on the line. Just hold near the line so you don't break it. And then the short one was a little harder. I had to use 2, but it worked. I have to cut off this piece, but these won't fit as is. So I used the Dremel with a little bit of a shelf and to grind away as much as I could without actually going over. And because it's round, I had to flip it over to make it look decent. And that seems okay. I sped up the video so you don't need to hear the crazy sound or anything else. But this was a pretty decent way of making them. But I will design them into the board so you have snap-off connectors next time. So they will be the same thickness as the board and you can just snap them off and use them instead. Hindsight, of course. If you're scared of this, don't worry, this will not be included in the final design. You won't have to do this. This is just because the part that I ordered never came. Thanks a lot, eBay. So they ended up being about 1 millimeter or 0.8, and it should be 0.6. So these are quite a tight fit. But they do fit. This is an old ribbon cable I had lying around. This is way too stiff, really, for this, but I just soldered it through the holes and then put some wires to the connectors in the front. The connectors don't go in all the way, so that's fine. They just go in a very small bit. So put the wire, solder it on, cut, pretty much. And I went all the way like this. This is K-NAR wire, I think 32 AUG or something. Okay, so time to solder the wires on the sides. Yeah, as you can see here, this is actually the problem. You need to, it's too far out and the actual connections are really bendy because it's so thin. So this is a really bad design choice by me. So I have to shorten this down so they're barely outside the holes. I'm just checking continuity so I don't have shorts. Not that this would destroy anything, these are just address lines. Okay, so I'm using my very own RGB out. As you can see, no composite. It's working very good. And I'm going to be doing an update on this, so you can see. I'm hooking in the connectors now. I need to do some testing with filters and stuff to make it even better, the RGB thingy, but it works really well. And I can capture my video from my capture card. I run it through the upscaler, so it's 1080p as well, so it's perfect for the capture card. Okay, so let's see. So I won't be able to put on the case lid because the wires are too stiff. So, and I'm using the Mega Drive plug or Mega Drive 2 plug that was broken. I fixed it finally. I glued it together. Okay, so let's take a look at here. I'm starting the power supply. I'm using a 9 volt 2 amp power supply. Nothing blew up. Perfect. Look at the nice clear picture. So you can see it glitching out sometimes. That's actually the noise in the that the upscaler doesn't like. I'm pushing the buttons quite hard now, but nothing happens. So I take the front off because it's not working. It's just me being ignorant. I have to push a lot harder because I need the rubber to deform to push the buttons. They actually work through the membrane. Okay, so let's see. It looks really nice. It looks like a real mechanical keyboard. So this is me in the future, obviously. So I used the tweezers to push the button and it works. But like always, I screwed up somewhere. I thought, at least. I thought maybe I had wired it wrong. 6, 7, 8, and 0, 9 I think weren't working. That's address line 11 on the keyboard. I checked the schematic, and then address line 9 as well. So everything under with Q, W, E, and so on. So after a while, I found out that I could actually push through the membrane. Just I have to push really hard, but you have a nice satisfying click. So that gives me hope for a little taller button. I don't need to push as hard, because the membrane doesn't need to deform to actually click the button. And it doesn't need to travel that far to engage the button either, so that's really good. As you can see, it works. It's not bad. I'm really happy with the result. So, pros and cons. It's a mechanical keyboard. It will last you forever. What could I improve? The buttons, obviously. And make the changes so you don't need to modify it. And have the connectors built in the motherboard so you can break them off and use them. So, as you can see, I ground down a bit. I thought I was being silly, but I actually fixed address line 11. It was actually on the connector side. You can see here. It's bent in, even if you can't see it. On one side it's bent in and it's not making good connection. So what I did, I just shoved in my tweezers and bent it up. And it's not apparent on the video that it's bent in, but I did move it a few millimeters to the sides and you could see it. This is on the microscopes. Sorry for the shaky cam. I can't really do anything about that. So I bent it up. Doesn't seem to be bent down, but it is. It's barely visible from this angle, but if you angle the board a little bit, you could actually see that it was bent. So just lifting up both sides equally, very, very slowly, so I don't break anything. And now it's protruding a little bit more. So this worked. This actually fixed address line 11. Address line 9 was just it was dirty pins. So 5, that one worked before. You can see the line on the top of these buttons. They're all connected together. That's address line 11. And they are working. So for next revision, I use different buttons. I think the footprint of the button I designed actually accommodates the bigger button. I'll order some and update with a small video. And some gameplay as well, because I won't be playing now because I have to push very hard. Hopefully you like this format of video. It's a little shorter, but it's more concise. And if you want more deeper explanation, just ask for it in the comments and will grant you a video. Have a nice one, guys. Bye.